3D modeling journey. You're just kind of walking along, and you're applying textures, and you see some weird stuff happening. Now, let me just demonstrate what kind of weird stuff you might run into. And it's a very common weirdness that will happen. Let's just say I got my monitor here. I don't know why, but I'm going to put a wood texture onto it. And you can see here are all the wood materials. You can go and you can search for wood in your asset manager here, and anything with the little Redshift logo. If you kind of filter out to just the materials that have the wood designation, you can see that there are all these really nice Redshift icon textures here. So these are Redshift compatible materials. So I just pulled one of the maple wood materials here. And again, I'm just let's just put this on the monitor there. You're gonna see, okay, well, it looks kind of good, but something's happening on the top here, and you might go and start up your IPR, and you'll see that, okay, kind of lucked out in that if we were looking at this point downwards, the material looks pretty good. But up here, there's all this stretching happening. Why is that stretching happening? Why is that weirdness happening? So the reason for this stretching has to do with a kind of complex topic called UVs. Now, UVs are a very important aspect of 3D texturing and using materials. And you might be wondering, what the heck are UVs? Well, UVs are basically a 2D representation, you can see here on the left, of a material and how a material is going to be applied to a 3D object. So you can see this little grid pattern. You can see how you lay out these polygons is how they're going to be mapped to a 3D object. So the process of UVing requires you to do something called UV unwrapping, which is basically unwrapping the polygons and flattening them out into this 2D representation, and then using this 2D representation to kind of move and place your texture along and kind of assign a different area on the UV map to an area on your 3D model. Now, again, it's kind of a little bit confusing. So here's a little representation of what it would look like if you were trying to texture a globe. So you got this flat 2D texture, and this is the UV map where you're trying to break down this sphere into a flat representation where you can then apply that flat texture, a flat 2D texture, onto that 3D model and have it look like an actual globe. And so it's kind of like if you had those little Christmas candies where it's like Santa, and you unwrap it and you lay out that foil flat. It's kind of like a UV unwrap. And you can almost think of it as if you ever had a sewing pattern to make a stuffed animal. Well, first you need to make the 2D representation of the pattern and then stitch together those flat pieces to form this bear here. So actually sewing patterns really helped me kind of understand what UVs were, considering that I love doing characters and I love stuffed animals as well and plushies. This is a really great representation of what's actually going on with UV unwrapping and why it's necessary. You got these 2D panels, you need to make a 3D object out of them, okay? So it's all about how you project a 2D image like this wood texture onto a 3D object. And you can see as you are modeling and you're extruding and you're pushing and pulling different objects around, well, a UV is going to automatically be generated. And when you're pushing and pulling and stretching those polygons, where you're actually stretching the UVs, like you can see here. So at some point when I was modeling this monitor, I stretched out some polygons that stretched out the UV. And of course, the computer doesn't automatically know how to map this material onto this object. Maybe someday with the AI overlords, they can read our minds and know how to UV unwrap and actually properly map a texture onto an object properly. But until then, you actually have to do this process of UV unwrapping. And so here's another example of like how would you apply textures to a little mushroom, where you would break this up into 3 pieces, flatten them out. So here's the top of the cap, the underside of the cap, and then the base of the cap. And you would just basically, you could either paint directly onto this 2D representation. You can do this in apps like Substance Painter, and you can directly paint on them, or you can apply a material in like Photoshop and have them mapped onto this UV map like this. And then you have that applied, those textures and materials applied to that 3D object. So that's why you need that process, because sometimes you're lucky and things just kind of work out, and sometimes you're unlucky, like with this model and you have this stretching. So how do we fix this? So I could just show you the whole process of UV unwrapping. It's a very complex topic, but I'm not going to do that because we're just learning how to learn 3D, and UVs is just a very complex topic. But I will link to a tutorial I did for School of Motion that's all about UV unwrapping and kind of covers the same stuff that I already did, and I walk you through the process of UV unwrapping. But instead of showing you UV unwrapping and all that stuff, what I'm going to do is introduce you to, I'll call it the game genie of texturing, that allows you to just kind of bypass UV unwrapping and allows you to apply your textures in a nice way without stretching. And this cheat code, this little game genie code, is called Triplanar. So what is Triplanar, you might be asking? Well, Triplanar is a method of generating UVs and sampling a texture and applying that texture to a 3D model by projecting the texture in 3D world space. So the input texture, like this wood texture here, would be projected once onto the world X, Y, and Z axes. So you can see that color code there. So Z is the blue, X is red, and then Y is the green. You can see how the texture is going to be kind of projected onto each of those world axis coordinates. And you can either have the same texture mapped along each of those planar surfaces, or you can put 3 different textures into each of these 3 different world axis coordinates. And that's why you would have something like this, where you got brick, wood, and then this little gravel here. And then you also have this little kind of blurring between these 3 textures. You're projecting different textures or the same texture onto each of those coordinates. And the cool thing about Triplanar is that you can project those textures, and then you can also blur between them as well to create kind of like a seamless texture. So let me go and show you how Triplanar works. It's a very simple concept, and we'll do it all in Cinema 4D and Redshift. All right, so we're back to our little monitor here. We're gonna fix the mapping of this wood texture using Triplanar. I'm just glad that the monitor is very happy, even though the material's all janky on it. So we got this maple wood material here. Okay, I'm just gonna double click it to open it. And then let's just go ahead and dock this node editor into the interface here. And then we can actually close out of the material manager. Now let's fix this with some Triplanar. So I've got my base color, which is just a texture node that has that wood material, that wood texture. And I'm gonna go and make sure my mouse is hovering over the node editor and just hit C. And then I'm going to search for, I hope if I spelled it right, Triplanar. And so there's that. Double click and add it to your scene. And then what I'm going to do is click on the Triplanar node, and you can see what I was kind of talking about, where what the Triplanar does is you can either have one image projected onto the X, Y, and Z surfaces, world coordinates, or you can just have one image projected onto each of the surfaces. So by default, there's the same image that's going to be projected on each of the surfaces. If I plug this into the color, the base color here, you're going to see that basically at this point, the image X is just this red color chip. So what we need to do to get this nice wood material projected onto each of those world coordinate planar surfaces is just plug in the base color into the Triplanar and have that replace the image X. So I'm going to plug this into image X. And then what you should see on the left here as it refreshes, voila, is the wood texture applied onto each of those Triplanar coordinates, which is really awesome. And so, like I was saying before, you can actually blur the images together. So that is controlled by this blend amount. So you can crank this all the way up to 1. And then you also have the blend curve, which is almost like if you had a Gaussian blur and you had a curves adjustment to either increase the contrast or lower the contrast. That's kind of what this blend curve is doing. So I can lower the contrast there. And so you can see we got this nice blended wood material. And with a lot of textures, this is a little bit more convincing, but unfortunately the blend amount only goes up to 1. So you can't go higher than that. But another thing you can do is you can kind of copy, command or control click and drag and copy this, because of course we also have other textures that are part of this. So we have a specular map, a roughness map. And so what we need to do is actually plug in all of these different maps into a Triplanar with the same settings, okay? and then plug that into the color there, the color reflection, and then command click and drag, and we'll just do the same thing with the roughness map here, plug that into roughness, and then lastly we will plug this into our normal. So our normal will go in here, image X, and then replace that input. And so now we have all of the different image textures in this texture set. So your base color, your specular, your roughness, your normal, they're all fed into the triplanar. And so if you wanted to, say, adjust the scale on all of these textures, you would have to go in and adjust, or actually go all the way down to the general here and adjust the scale here. So remember, lower numbers makes the texture bigger. So 0.5 and 0.5 here. So this will be a bigger wood texture, or we can make this smaller by entering a bigger number. So say 2 and 2. And you can see that the bigger textures, the blur kind of like falls apart. But with a smaller texture like this, it actually looks a lot better. And I wish you could actually blur this a lot more than you can here. But this is looking really nice, and it's a lot better than what we had before without the triplanar node. So whenever you have an issue with your textures being stretched, your materials being stretched, try a triplanar node. That's the game genie. You just call it a day. Put the triplanar on it, set it, forget it.